Hello, and welcome to our lecture on cognition and thinking. So, cognition is all the mental activities associated with thinking, knowing, remembering, as well as communicating. A mental representation is a bit of memory representing objects, events, people, and other things not actually present. We tend to think in visual terms. Even when we are imagining events, we tend to do so using a visual format before other sensory approaches. Behavioralism. John Watson is the founder of behavioralism. Watson believed thinking was essentially a matter of talking to ourselves. Watson believed thinking involves specific motor actions. Tiny movements of the tongue and throat occur when we think. Evidence did not support this since thinking can be independent of any motor action. B.F. Skinner termed thinking as behavior that is on a smaller scale and is usually verbal and unobservable to others, sort of as a covert behavior. And a covert behavior is a behavior that is not able to be observed in another person. So thinking is an example of a covert behavior. We could revoke the behavior if the private consequences were not reinforcing. And most psychologists agree that thinking is more than just a covert behavior. So there's still behavioralists when it comes to psychology, but some of them have sort of moved beyond that process. Mental images. Mental images may take the form of visual imagery, auditory imagery, smell imagery, or even tactile imagery. Bottom-up processing. This is a real image. It goes from a sensory receptor to the brain. Top-down processing is a mental image. It goes from the prefrontal cortex to visual or audio or even other areas of the brain. Concepts. Now, concepts are cognitive, sort of categories for groups or grouping of events, grouping of objects, or even processes. A mental grouping of similar objects, events, ideas, and even people. Concepts represent categories or kinds of things and their rules of combination, not just an individual case. Most of our knowledge is in the form of concepts. It helps us to think and function effectively. It provides a sense of order and range from broad to very specific. We organize concepts into hierarchies or categories by recognizing their association and, similarities when it comes to sort of a prototype. The association theory. This was proposed by Clark Hull, who described concept formation as the acquisition of stimulus to stimulus association. We learn to associate a concept with the set of stimulus that share one or more common elements. So a ball with roundness, small, hard, soft, whatever the case may be. This allows us to adapt this novel instinct or instance of other concepts, and we respond correctly based on that generalization. The exemplar theory. This is the theory that the natural concepts we form every day in everyday life are structured around prototypes or typical representatives of categories, such as robins and jays as a prototype of the concept of a bird. The prototype is basically defined as the best or most typical representation of a category around which we often structure our concept of that category. It's sort of a mental image or best example of a category. Matching new items to a prototype provides a quick and easy method for sorting items into categories. The more closely an object or event matches our prototypes for a concept, the more readily we include them in a category. Problem solving. Problems consist of three components: the original state of the situation as it exists in the moment, the goal state, which is what the problem solver would like the situation to be, then the rules or restrictions that govern the possible strategies for moving from the original state to the goal state. A problem exists where there is a difference between your present status and some goal you wish to obtain, with no obvious way to bridge the gap. It's different from simply executing a well-learned response or a series of behaviors. Problem-solving behaviors involve three local steps or stages, sort of a logical way. First, representing or defining the problem. The circle problem, the triangle problem, the chain problem. The second is generating possible solutions. The third, evaluating how well a given solution will work, and then making your decision, solving the problem. Strategies for problem solving. Number one, trial and error. Problem solving strategies that involve trying possible solutions one by one until we find out what works. This is good with a limited number of solutions. Example, restarting your phone, turning off the Wi-Fi, turning the Bluetooth on and off. The second is testing hypothesis. This is a problem-solving strategy that involves formulating specific hypotheses that generate relatively efficient approaches to solving a problem, and then testing those hypotheses in sort of a systematic fashion. Three is algorithms. This is sort of a methodical, logical rule or procedure that guarantees a solution to a problem. Computers and people may use algorithms to find the correct answer, following a set steps to sort of arrive at the solution, a recipe, a math formulation, things like that. It's a guarantee a correct solution, but may be ineffective and more sort of deductive. And then intuition. This is an effortless, intermediate, automatic feeling or thought as contrast with explicit, conscious reasoning. The next is means end analysis. And this is identifying the difference between an original state and a desired goal, and then processing through a series of sub-goals to reach a solution. I want to clean the house. What are my sub-goals in cleaning the house? I need to get the cleaning supplies, clean the kitchen. You have these steps. You focus on sub-goals that are not necessarily sequential. The next is working backwards, sort of describing the goal and then defining the steps that directly precede that goal by working backwards in this manner until the steps needed to reach the goal are clearly defined. You want to be a nurse, you need to pass the certain exam, you need to graduate from the school, you need to pass clinicals, you need to have knowledge based on the class, you need to learn the materials, you need to study the materials, you need to record it. Sort of these steps, right? So sub-steps are very common in math as well as logical problems. I hope you've enjoyed this session.